All right. We are going to talk about the difference between an observational study and an experiment. Then we're going to talk about confounding and how it limits the ability to make cause and effect conclusions. Then we're going to identify experimental units, explanatory response variables, and treatments. So an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. We just observe what's already happening. We do not impose a treatment. So to be an experiment, we have to impose a treatment. So just recently in the news, they said taking Tylenol while pregnant might cause autism. Do you think that is observational or an experiment?
Observational.
Yes. Can they tell you when you're pregnant, you're going to take Tylenol and you are not going to take Tylenol? Should we randomly assign that to women? No. So it's observational, okay? If I didn't look at any data or anything, I just saw it in the thing. I have no idea. All right. But it's observational, okay? An experiment would be imposing a treatment, meaning I'm actually going to make some women take Tylenol and I'm going to have others not take Tylenol. All right. Same with texting and driving, right? That would be observational, okay? We never told these teenagers, you guys go text and drive for all of today, and you guys don't go text and drive, all right? That would be very unsafe. That would be bad, okay? All right, good. Does taking hormones reduce a heart attack risk after menopause? Should women take hormones such as estrogen after menopause when natural production of these hormones ends? In 1992, several major medical organizations said, yes, women who took hormones seemed to reduce their risk of heart attacks by 35 to 50%. The risk of taking hormones appeared small compared to the benefits. All right, the evidence in favor of hormone replacement came from a number of observational studies. So in other words, they drew this conclusion that taking these hormones reduced heart attacks, but they did not randomly assign treatments. They did not impose a treatment. They just observed some women took some hormones and they observed fewer heart attacks. And some other women didn't take hormones and they supposedly had more heart attacks. So what do you think the women had in common who took hormones? They were wealthier, probably. Probably because they have more access to medical care. They're going to the doctor more often. They probably sought out some kind of medication, okay? So they have something in common. Maybe they're just healthier, right? Maybe they like also eat really healthy and they also took hormones because they're just conscious of like what they're doing. I don't know, okay? But they have what's called a confounding variable. It was something else that was actually causing the reduced heart attacks, not the hormones. So, what'd you say? Oh, you're doing this inside? That's funny. Yep. So maybe these women, again, were just healthier overall. Maybe it was the healthier women who took hormones, or maybe it was the wealthier women who took hormones, which means they had better access to health care. And it was actually that access to health care that caused fewer heart attacks. All right, response and explanatory variable. We want to know the difference. It's kind of like an X and a Y variable. Response variable measures an outcome of the study. Okay, that's the Y variable. This is like the output, all right? I think of it as X and Y, all right? So this is like the Y variable. An explanatory variable may help explain or predict changes in a response variable. So the explanatory variable is like the X variable. Bless you. Bless you. Bless you. Bless you. So in the hormone study, the explanatory variable is basically hormones, if they're taking them, the women who took them, and no hormones, the women who didn't take any. That's the explanatory variable. All right, the response variable that they looked at was number of heart attacks. Now again, we had a confounding variable because this was not an experiment, because we didn't assign hormones to women and no hormones to women. If we did do random assignment, and therefore we got all kinds of different women taking hormones or no hormones, and we did then see a reduction of heart attacks in those who took hormones, that would be a legitimate study, okay? All right, if you are asked to identify a possible confounding variable in a given setting, you are expected to explain how the variable you chose is associated with the explanatory variable and affects the response variable. All right, so you need to connect your confounding variable to the X and the Y. In other words, if I choose wealth, okay, if I choose wealth as my confounding variable for the hormone study, I need to say, well, the wealthier women probably are the ones who took hormones. And it was actually their wealth or access to medical care that caused the reduction in heart rate, okay? As long as you connect it to both, you can pick any confounding variable you can think of, okay? Whatever your brain comes up with. A lot of times they'll give you something that hopefully you can think of something, okay? An experiment was done by medical researchers to determine the association between drinking caffeine and severity of lung cancer. Results showed that there was a high association between the two variables. Which of the following could be a confounding variable in the experiment? What do you guys think? I agree with you, okay? First of all, caffeine consumption is the explanatory variable. Lung cancer is the output. That's the response variable we're looking at. These are just people involved in the whole study, I guess, all right? Smoking, we know, after years and years and years of observational studies, we do know that smoking causes cancer, even though we didn't random assign it. Okay, sorry, don't do it. All right, so smoking causes cancer, but we have to relate these people together somehow. And so you're going to make something up like this. Maybe those caffeine drinkers like the high of caffeine, so they also are likely to smoke, okay? I don't know that this is true. I mean, I drink coffee, so, right? But you relate it in some way, right? They go together somehow. They're more likely to smoke, and that's what's actually causing the lung cancer, not the caffeine. Yeah, I know. I do really drink coffee. Okay. All right. Does eating dinner with their families improve students' academic performance? According to an ABC News article, this was a while ago, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. Was this observational or an experiment? So did they tell kids you are going to eat with your family once a week, and you are going to eat with your family twice a week, and you're going to eat with your family 3 times? Did we randomly assign the amount of time these kids ate with their parents? No. Okay. So we did not impose a treatment. So is it observational or experiment? We're just observing. Okay, we're just observing. All right, justify your answer. You pretty much always say, when it's observational, no treatment was imposed, right? I did not impose an amount of days for you to eat with your parents, okay? What are the explanatory and response variables? What's the explanatory variable in this problem? Yeah, it's like how often you're eating with your family. I guess maybe they split it by 5 times a week or more, and then 4 times or less, okay? And what's the response variable? Your grades, your GPA, okay? And again, do we have cause and effect? The only time you have cause and effect is when you randomly assign treatments. So I would have had to impose a treatment, and it would have to be random. That's the only time you can have cause and effect. So do I have cause and effect? No. What could be a confounding variable? Sleep. Now, if you pick sleep, you got to relate it to eating with your family. Yeah, better moral support. All right. Maybe if you eat dinner more with your parents, they enforce a bedtime. I don't know. I'm making something up, right? That you got to relate that, and it's actually the sleep causing you to have better grades. You could say that. I don't know. I did it for it. All right. All right. What is an experiment? Oh, good. All right, a specific condition applied is called the treatment. So if I'm going to say you're going to eat dinner with your family twice a week, you're going to eat with your family 5 times a week, that would be a treatment, okay? If I'm going to assign Tylenol or no Tylenol to pregnant women, that would be a treatment. All right, some of that would be illegal. I'm just saying that would be the treatment. All right. The experimental units are what you're applying the treatment to. All right, so the experimental units in the hormone study are the women who took hormones and didn't take hormones, okay? And if it's human beings, we often call them subjects, okay, what we're applying the treatments to. Malaria causes hundreds of thousands of deaths each year, with many of the victims being children. Will regularly screening children for the malaria parasite and treating those who test positive reduce the proportion of children who develop the disease? Researchers worked with children in 101 schools in Kenya, randomly assigning half of the schools to receive regular screening and follow-up treatments, and the remaining schools to receive no regular screening. Children at all 101 schools were tested for malaria at the end of the study. Identify the treatments and the experimental units in this experiment. What are the treatments? Anyone raise their hand and tell me what the treatments are in this? Yep, what do you think, Max? Yeah, so some of the schools got screening and follow-up treatments, and the others got no regular screening. Okay, that's the treatment. All right, and then experimental units. Raise your hand if you can tell me what the experimental units are. Somebody different. Addie, what do you think? Yeah, it's actually the schools, but it is the students in the schools. So either way, yeah. All right. And that's it. Oh, there we go. Okay, boom. Experiments can give good evidence for causation. This is a really, really, really important, okay? Random assignment is the only way we have cause and effect. Okay? Random assignment, which is only in an experiment. Okay, you don't do it in observational study, you don't do an experiment. Okay, random assignment is the only way that we have cause and effect. Now, there might be a correlation or an association, okay? That's what happened in the hormone study. There was a correlation or an association with a confounding variable, okay? We do not have cause and effect. So correlation does not imply causation is another one you'll hear. right? Just because two things kind of look like they're trending together doesn't mean cause and effect, all right? In an experiment, a factor is a variable that is manipulated and may cause a change in the response variable. The different levels of a factor are called levels. So a factor is essentially an explanatory variable. It's like another word for explanatory variable, all right? This is where you're maybe saying, hey, you guys are going to eat with your parents 2 days a week, and you guys are going to eat 3 days a week, and you guys are going to eat 4 days a week, and you guys are going to eat with them 5 days a week, right? Those would be the different levels of the factor. So the factor is the nights per week you're eating with your family, and the levels would be the different nights, however many different nights, okay? Or if you were doing Tylenol, you could certainly apply different levels of that drug to test its effectiveness on headaches or something like that, okay? Have you ever dropped a tasty piece of food on the ground and then quickly picked it up and eaten it? If so, you probably thought about the 5-second rule, which states that a piece of food is safe to eat if it has been on the floor in less than 5 seconds. The rule is based on the belief that bacteria needs time to transfer from the floor to the food, but does it work? Researchers from Rutgers University actually tried it. Gross. They used 4 types of food: watermelon, bread with butter, and gummy candy. They dropped the food onto 4 different surfaces: stainless steel, ceramic, tile, wood, and carpet, and they waited for 4 different lengths of time: less than a second, 5 seconds, 30 seconds, and 300 seconds. Finally, they used bacteria prepared 2 different ways in a tryptic soy broth or peptone buffer. Once the bacteria were ready, the researchers spread them out on different surfaces and started dropping food. My toddler eats it, like, he's gotten better, but he's gross. Like, just stuff out of the car. Who knows how long it's been there. It's like, it's nasty, all right? But he's alive, so. All right. He has had a lot of diseases. He's been sick a lot. All right. So, that's gross. All right, listen. Building up that immune system. All right, list the factors in this experiment and the number of levels for each factor. What is one factor? Yes. Time, that it was on the floor. What's another one? Type of food. Okay, what's another one? Yes. Yes, the floor surface. And the other one's the bacteria on it. Okay? So those are all of the factors. And then are you guys good with the different levels, right? Okay, of each factor. Great. All right, if the researcher used every possible combination, how many treatments are in the experiment? There are a ton. There's 4 types of food. There's 4 types of surface. There's 4 amounts of time, and there's 2 levels. That's 128 treatments. All right, so you multiply them all together, and you could get every combination. All right, list 2 of those possible treatments. They'll ask you, basically, are you understanding what's happening? We used watermelon, stainless steel, less than 1 second, and tryptic soy broth, or gummy candy, wood, 300 seconds, and peptone buffer. All right, there you go. So it's any combination of those 4 different things. All right, you guys. Okay, 4.2a worksheet. Oh, I know. Let's get it done. We got this.